Okay, we're going to start today with a couple of announcements and changes in kind of schedule here. First, the announcements. Um, a while ago, I posted about the Women in AI Data Science conference by Mini Analytics down in the Twin Cities. I have a van reserved for that. I'll be going down to that November 4th. So if you need want to ride on the van, you can sign up for that. It's just a college van. We're going down in the morning, coming back in the evening for that event. I was going to say, if you haven't registered, you could do so, but the event is now sold out. So if you didn't register, I'm sorry. So, but there. The other thing I just want to point out, a quick reminder that today is the last day to update your voter registration online there. So remember, as a college student, you can vote either here or in your hometown. Uh, but generally, you want to check your voter registration to make sure it's updated with the correct address here. And today is the last day you can do it online. After today, you simply have to do it wherever you vote. So wherever you go vote, you can update your voter registration there. Also, if you didn't see the last week's Ask a Professor program where 4 faculty talked about the election, I included a link to that. That's here. So that's my reminder that you should vote. And also, if you don't know, you can vote in person or you can vote now. I've already voted. I vote by mail every year there. I like that because then I can take my time to read the ballot. But you can also go and vote early. There's 2 locations in Duluth, open most days, 8 to 4:30. So you can vote anytime between now and election day. And again, same with your hometown if you're there. There are a couple weekends that you can vote when we get a little close to the election early. So, okay, what am I changing? You say, Tom, are you changing something? So, we're going to do um unit 7 here, and we're going to do the quiz this week. And normally we do the quiz in class, but it's open book and take home quiz. And about a third of the class is probably going to DigiKey. And I don't know when you're leaving for DigiKey. Are you going to be here Thursday?
Thursday at 4, so we'll be here.
Oh, so you'd be here in class. So, but anyway, I didn't know if you'd be here or not. But anyway, I thought about it. I'd rather do a learning activity. I want to do this learning activity on microservices. Uh, and it's kind of complicated. I'm working to simplify it there, but I think it's going to be harder than the quiz. So I'd rather do that in class where we can all work together on that and make sure we get that going and have you take the quiz at home. It's an open book, open note quiz there. So that's what I'm going to do. So the quiz is due. So we won't have an assignment. I should post that. There'll be no assignment this week. Instead, you'll take the quiz here for this. So that's the plan. The quiz is worth 25 points. It's 5 essay questions that you have to answer. You can use your book. You can use it. The one thing it is it's timed. So you have 90 minutes to take it. So once you start the quiz, you got 90 minutes to answer the 5 essay questions for that. Here. Um, so we're gonna do a little bit of a review today. I think it's good at times to kind of stop back and see what we've covered, remind ourselves. I mean, that's the whole idea of the quiz is to figure out, make you reflect on what you've learned, revisit that. I mean, there's a lot of research that shows that you just see things once, you forget it. If you see things once and then go back after a while and see it again, that helps you remember it long term there. So, I mean, that's one of the whole ideas behind quizzes or review things and stuff like that is to force you to do that. So we'll do some review today for the next 55 minutes, and then we have a guest speaker, Leah, experience. So Lee has worked for a number of interesting companies. She's currently working for Infinite Campus down in Blaine, Minnesota. She's a software engineer tier 3, which I think is the top tier. She graduated in 1999. So she's not me old. She might seem old to you, but she's not Tom old. Okay, so that's where she fits into that whole thing. So she's agreed to Zoom with us. She'll be joining our Zoom around 11 today. So that. And then next week, Rihanna will be Zooming in. She's now at a new company. She's worked at Thomson Reuters down in Twin Cities. Also, she's a 2012 grad there. And then the following week, we'll do James. James works at a startup out in Seattle. He's worked at a number of startups, so it's always interesting talking to James and what life at these startups are like and how that feels compared. It's very different than like Securian or DigiKey, I think, in some ways with these startups. So we'll do. We're also Federated Insurance is going to come here and recruit that day and probably buy you pizza. It's not a bribe. It's just a thank you gift for listening to them. So that's what it is. So Federated Insurance. So they're going to come to class for half an hour to talk about Scrum and how they do Scrum at Federated. And then they'll buy us pizza afterwards. Kind of like DigiKey did. So that's our next couple weeks here. I'm trying to get a couple more speakers. So I want to try to get Michael Ford back here. He's done a lot of work as a game design tester, which doesn't fit in this class, but he's got some really fun stories. So I thought that'd be fun here. So we can see if we'll see if we can get him in there. Okay. So yeah, guest speaker, we have Leah coming in today. So we're going to do a review today, kind of go over what we've done in this class. So again, if you remember way back in the day, we talked about Scrum in the beginning and what Scrum is there. And I'm bringing up the textbook now here. Okay, and you've used Scrum. Well, see, the problem is that we pretend to use Scrum, but we really don't use Scrum in any of our courses. We try to bring in components and talk to you about it, but Scrum requires things like daily stand-ups. And so it's hard in a project to have daily stand-ups when, everyone has different schedules and we can't all stand up and meet at 9 o'clock every day for a thing. So it's just in the capstone project, Brandon runs that like an agile methodology, but you have weekly stand-ups. You have weekly stand-ups. Which is different. But again, he tries to show you what that is like for this. He'll have some of the stuff like after a sprint, there's usually a reflection on how things went. And it's interesting because I always thought that was a made-up thing. That's something we say we do, but people actually don't do it. But when you talk to these people who are actually out there in the field, in this class, a lot of them do the end of sprint reflections. And again, the planning at the beginning of the sprint on what they're going to do for that sprint and the presentation to the stakeholders at the end of every sprint. So those, we've already heard speakers talk about those stuff. I'm trying to get another speaker, Misha, to get in. He works at a startup on the West Coast. East Coast, there in Boston. And he was telling me we are going through the Scrum stuff he does, and very similar to what we've actually said here. So we talked about Scrum, story points, Scrum boards with their swim lanes and their backlogs of events of tasks they want to do there. We've talked about user stories. for that. I still think that this user story template as a blank, I want to blank so that I can blank is common. I have yet to find people in industry who say they kind of use that format. They just write out their user stories and what they're supposed to do. So I'm not quite sure how common that, I mean, it's common in all the textbooks and stuff, but we'll have to ask some more people when we do it. We talked about what technical debt is, story points. You remember, so what was a burn down chart? Do you remember what that was? So you remember what a scrum board was with like the post-its that moved across there. Do you remember what a burn down chart was? So during a sprint, a burn down chart tries to show how many points it starts up high with it. So let's say we want to do 30 points of work in the sprint. Starts at 30, and as everyone does things, that drops down. So if someone completes a task, a story with 2 points, it drops down to 28 on the next day. And the next day, someone completes another task, it'll drop down and drop down and drop down. So that after over like a 2-year sprint, it should drop down to 0. So it starts off at however many story points you have planned to do, and we want to show that we've done all those tasks for this stuff. We talked about the daily stand-ups, the retrospective, that's what it's called at the end. I keep calling it a reflection, but it's a retrospective stuff. So again, you may want to review that and reread the text. There'll be a couple, or at least one question related to Scrum and Agile development for this. We talked about C# programming versus Java. Here we did that. We talked about some new things in C# properties, which are like getters or setters, but they're built in to C#. And so you don't have to say like wages dot or like get wages, or if you have a let's say you have a customer and you want to check out their age, you don't have to say customer.getAge. You can say just customer.age and use it like a variable. You don't need to have a get or a setter, and then the get or a setter is called implicitly when you reference that variable or that property for it. Or if you set customer.age equal to something, it'll call the setter appropriately for that. So we talked a little bit about properties. That's one thing that was different here. We looked, we format the inheritance a little different we don't say extends, we just have a colon in there for that. So there won't be much on the quiz related to this Unit 2 C# again, because we've just been doing that. So I don't think there's much that I can remember on the quiz related to that. Then we got into dependencies, model view controller stuff here. So we talked about how you set up dependencies in Visual Studio here, and we'll be seeing more of that going forward now when we start doing like these microservice projects here. So we're used to, like in Java, saying like including or talking about using when we want to reference another library or another activity here. So if we have a controller here, and this controller uses stuff in another folder, another area here, we're used to using this, saying using and then referencing that object here. What is it in Java? Is it import? So I learned pound include because that's how C does it. So in my mind, it's always pound include, and I have to translate that into whatever new language this is, like Java. So yes, using. No, import. Right. So you're in every language, there's something like that here. But that works if everything's in the same project here. If we have multiple projects for this, we have to go to dependencies. We have to do this using, but we also have to go to dependencies and we have to add dependencies. So if there are multiple projects, they'll be listed here, and we can click on another project, say include this project or references to that project in this one, so that one project can reference stuff in another project. And we'll see when we get to microservices that every microservice will generally be in its own project here. So it'd be more common here. Now we do see this when we do test projects. We'll come back to this when we get to unit tests. We'll see the same thing. I don't think we really talked about NuGet very much yet, and I don't think we've really seen it not. So that's the package manager. Again, sometimes if you're on some system and you've had to import something, NuGet will go out to import it, but it's usually done in the background of bunch here. We talked and we started to see this dependency injection. Do you remember what that was? So that is like if you have an object, a class, and it needs another class, we don't instantiate that class inside the other class. So let's say we have a just a an order class, and we need access to the customer database or customer repository class there. We don't necessarily just instantiate a customer repository class. We will pass that in to the order class and say, here is the customer repository you should use. So again, we'll tend to pass objects around to objects that need them there. And that'll make testing, writing unit tests easier, because then in the unit test, we can also just pass in an object of that type or a fake object of that type to the unit tests for that here. We really haven't talked too much about RESTful web services. We will get more into them starting this week. We'll start creating RESTful web services with microservices here. So this will be our way of, this is how we'll have different microservices talk to each other with a REST, they'll create a RESTful API, and we'll talk more about that. So. We talked about model view controllers, and again, we looked at these websites that have a model folder. So we have like a student model, that's the data for the student. They'd have a controller, which would be set up how we have to work with the different web pages and modify that. And then we'd have a view. And so in our views, we'd have like a detailed view, and then the view is largely HTML or this ASP, CIS HTML, where we've got C# embedded in our HTML. So that's how weird that .NET generally does model view controller sort of stuff. We talked about a little bit. We haven't looked at object relational mappers yet here. We've talked about them. I'll just warn you, I just don't generally quiz you on stuff that we haven't actually done. So we've talked about, but we haven't done it. So I don't think it's in this quiz, but I think it's in the final exam quiz, because by then we'll have created ORMs or used certain ORMs there. So again, when we're using a database, like we go out with SQL and get a query, get the results back as some sort of some sort of table or something. We want to then convert that into an object there. So if we go out into the patient table and query, I want this patient by patient ID, it'll send us back a patient, but in SQL format, kind of as a table or as a JSON file or something like that. And we want to convert that into one of our patient objects. And that's what the object relational mapper does for us. So, and again, we looked at the student model view controller website example here a little bit. Then we talked about interfaces and patterns for this. So we talked about how an interface is different from the class and how we implement an interface for that, how we define that. And I also talked about how interfaces are different than inheritance here, but you can do what we call polymorphism for both here. You can have let's say we want a number of objects that can be treated the same somewhere. So like in game design, maybe you want a number of objects that can be used as a weapon there. So we might have, and so, you might have different types of weapons, ranged weapons, hand-to-hand combat weapons, just miscellaneous objects you find around. Can that be used as a weapon? Can I club someone over the head with this rock here? So with inheritance, you'd have a parent class that would be like a weapon, and then everything would be a child of weapon, right? So a bow would be a child of the weapon, and a sword would be a child of that weapon, and maybe the rock would have to then be a child of the weapon. And then we can pass any of these objects to like inflict damage method, and every one of these objects would have an inflict damage routine, and it would be different. The way it calculates damage would probably be different for each of these objects there. But they'd all have the same routine because we can guarantee that because they all inherit from the weapon parent, and then we can define a method like inflict damage in the parent that all the child have to do. So that we have this method called abstract method. So we can define an abstract method in the parent, and then every one of the child classes have to implement that method. So we can do that with inheritance. But what if we also want some of these objects to be able to be put in inventory there? So we want them to be able to do damage as a weapon and also be stored in inventory. So to do inventory, we need them to inherit from a generic like inventory object that would be able to display an icon on the screen and have its information, display some information about itself there. So the problem with inheritance is that you can only have one parent in programming languages. So if your parent is a weapon class, you can't also be a parent to inventory base object, but you can implement multiple interfaces. So that's one of the main goals of interfaces, is that you can implement multiple interfaces. So you can say, oh, I'll implement the weapon interface and I'll have a get damage method there. I'll also implement the inventory interface, and then I can be treated as an inventory object, and I'll have a get inventory icon method to just give a little icon to display in inventory or something like that. So you can with interfaces, you can implement multiple interfaces. So we talked about some patterns. We talked about the null object pattern, some way to get around this null objects. Again, when you define a variable, the typical example is you define a variable or you call a routine that's supposed to return a variable to you for for this. And then later on in your code, use that variable, so maybe you're getting a patient from the database, or you're creating a patient or something like that. And then you say patient dot name to print it out. If patient is null, at some point where you thought you got a patient, you didn't get one, you got an empty null back. When you say patient dot null name, your program's going to crash and burn. You're going to generate an exception there, and if you don't catch that exception, everything's going to crash there. So this null object pattern is a way of maybe like when you ask the database to go get this object, and if that object isn't in the database, it'll return to you a null version of this object. So then later on your code, you can say patient.name and it won't crash here. Now there's ways you can always just check if the patient is null, and if so, if it's not null, then do that. But we try to get away from all of those checks of is patient null, do this, is patient null, do that. So the object adapter pattern, I think, is one of my favorite patterns here. Do you remember at all what the adapter pattern did? We did that. What did we do? Insurance?
Yeah, it, like took code, from a class that we couldn't modify.
Yep.
And then we had to implement it so we could modify it within our insurance interface.
Right. Yeah. So there was an interface we needed it to do, the insurance interface, and there was an object that we couldn't modify that didn't implement that interface, right? Yep. And so we created an intermediate object in between there that created one of those immutable objects there, and also implemented the interface and did some translation. So yeah, I think you had to translate things from, like, we had one of the methods return yes and no, and the interface wanted a Boolean true false, I think, and so you had to convert the string yes no into a Boolean true false sort of stuff for that here. I was actually thinking, and yeah, I'm not sure. One thing we don't do in this class, I'm trying to figure out where to fit this in, is some code inspections here, where we'll actually look at code and try to give recommend some changes to the code for that. So I was looking at everyone's different object adapters, and it's interesting how there's a couple standard ways of solving those problems there, and but there's not just one way of doing it. So it's interesting to look at that. The strategy pattern we talked just briefly about. Again, that's a pattern where we're using kind of interfaces, and we have a number of different objects that can implement an interface, and you can choose between them on which of those, and you usually have some strategy object that determines that. Always think of this kind of in terms of like a non-player character in a video game, where there's depending on like how close the player is to this NPC, you might have different actions or different strategies, and then maybe depending on if this non-player character is how healthy is it might have a runaway strategy, might have a attack strategy, it might have a wander aimlessly strategy there, and all these strategies can implement the same interface. And so then it's easy for this non-player character to switch between these different strategies here and choose to do different things. Yeah, and then like we were just talking, we did the out network adapter example. So we created this out network adapter that implemented our interface. We define a patient here, and then in the constructor we create this patient here, this out network patient, and some of it is pretty straightforward. So like if we need in part of the interface, we need to find a get patient name. And our object, our outpatient has just a get patient name. So just get patient name calls patient get patient name here for this. But sometimes, again, we have to do some conversion. So coverage amount, we want to return the amount of coverage given the cost of a procedure. And again, our patient, our out network patient returns a percent, not a procedure cost. So we can give it a procedure cost and it just returns a percent covered. So then we have to multiply that percent covered by the procedure cost to get. So again, we have to do this. I often think of this in my mind. There's a term called middleware that translates from one type of system to another system. It's middleware. And I always think of adapters kind of as this middleware that helps translate from some old or some system that you can't modify or that other people control, and that converts it to your system here. And here's the is covered. We want to return a Boolean there. We are getting the policy number. We're checking if it's covered here. If that's yes, we'll return true. Otherwise, we return false here. Here's one example of code. So we're asking if we check if the patient's covered, and that's returning a yes or a no there. And we check if that equals yes. And if it equals yes, we return true. So if that's true, return true. Otherwise, return false. Does this code bother anyone? Why? How would you redo this code?
You could just replace the if statement with a return patient dot is covered patient name. Probably saying like it would return that Boolean from that method call.
Right. So something to watch. And again, some people argue that this is clearer, but I don't. So here's the thing. We're saying if this is true, return true. So return whatever. And if this is false, return false. So return whatever this is, true or false. So if that's the case, you should just say, you don't need this if, right? You can just say return that. And that's a true false statement there. So I think that's a better way to write this than this return true false stuff. Okay. We talked about unit testing. What process did we use to define our unit tests? Better Business Rule, was it triple B's? No, it was triple A's, right? What were the three A's there? We have to set up the test, we have to do something in the test, and we have to test the test there, right?
Active, assert.
Arrange is the setup, act is when we do something, assert is when we do the test there. So we did our arrange, act, assert structure for our tests here. We talked about how these are set up. So again, usually in these tests, let's close some of this. So if I'm in a test, I can often then say generate some unit tests. So again, if I'm in a class, I can actually ask Visual Studio to generate the unit tests. Say okay. Now will have one solution here. It'll create a separate project for my unit tests here, and it'll create then a method for my unit tests, or a class for my unit tests. So here I said create unit tests for a student repository. So I have a student repository tests. We some annotations here for those tests. And then again, we would then add our arrange, act, assert in each of these tests for this. We talked about running these tests, right? We run all the tests. There's some, we usually test Explorer somewhere in our system that'll show the tests running and will show which ones will pass or fail. These are all set up to just fail because they're not actual tests here. So those are run over there. Here's a question for you. Do you know why one of these is, we have two, so now we have two projects in our solution. Why is one of them bold and one of them not bold? Anyone know why this project is bold and this project is not bold? What was that?
One of the tests.
Yeah, one is the test, one is the project. One is set up to be the main project that runs when we click here. So this is the default project. It should have a main in it that it knows how to run here. So we'll see that for that. And in most cases, there should be just one project that's bold, and that is the project that'll run here. We'll notice strangely, when we get the microservices, we'll try to set up multiple projects that'll run because we want to run multiple services at the same time there. So, okay, so we talked about testing here. Talked about how we set up unit tests in Visual Studio. Test-driven design, we talked about briefly, where, again, that's where you write your unit test first, and then you write your code to do the unit test, to pass the unit tests. Sometimes that's called test first process, where again, when you're going to add a feature or user store, you have a new feature, new user store you first create a couple unit tests to show when that's going to be working, and then you start doing your code until those unit tests pass here. We talked about this red-green refactor here. So our tests generally start off as fail as red. We update our tests till they turn green here. Once they're green, we can refactor. We can, clear up our code, remove some technical debt, and keep them that way. I was just teaching refactoring for the first time in Java 1 for this. When we were learning how to do methods or like subroutines. They didn't know how to do methods or subroutines. So we're talking about how you have this code that's big and breaking it down into separate methods there. So and making some generic methods and maybe passing some parameters there. But you do that, your code works as one big chunk. But again, it's hard to read and update. So if you break it down using some methods, that will help organize it here. So that hopefully makes sense to you. You're used to thinking about taking code and breaking it down in the methods there. We are going to next week talk about the next level of that and taking classes and breaking them down into smaller classes. There's something called the single responsibility principle, where we'll refactor our code so that every class does only one thing. And so we'll try to figure out. So we'll end up with more smaller classes than what you've probably been working with. And classes will not often have as many methods as you did before. So we'll talk about that and when you might want to do that. So, but we talked about refactoring here and red, green, refactor. We talked a little bit about these mock stubs or fakes. Again, when you're doing unit tests here and you want to program something. So like here, we're testing out a student repository. the student repository needs access to a database, but again, we often are going to want to run these tests without access to the database. So often we'll create a fake student database that we can access in our tests for that. And again, sometimes that's called a stub or a fake test or a mock test. Has anyone worked with in companies where there's been a QA person, someone who just did testing and stuff like that? So often those people do it at above. So again, what I'm kind of getting is there's this idea of that the developer often, I think, does unit testing and then it's handed off to QA people who do like some sort of larger testing. Is that how it worked at your place?
Yeah, she wasn't like writing code, but she would basically go through the application.
Uh-huh.
You know, test everything, click on buttons.
Okay.
And deeper, more complex tests too.
Right. So
it wasn't as low level as the code.
Right, yeah. And so that's how it usually works. And again, often like in a sprint, as developers update their stories or do, their feature, their stuff, they'll write and pass unit tests. But then we have to check if this all goes together okay, but one thing didn't break another thing. So often we bring all the changes, and this is usually done. You can also think of this within like GitHub. People have pulled their branches off, they've done unit testing on their branches, now we're pull this back up. And so you may have just updated a controller and wrote some unit tests for a controller, and someone else updated the repository, the student repository, and ran unit tests like that. Now we're going to pull all those two different branches together, and someone's going to run all the tests again and maybe some new tests on the whole system to make sure that someone's changes do not hurt someone else's part, code or some other part of the system here. We talked about refactoring. We didn't do too much on that. Again, I don't love the chapter on refactoring. It talks about magic numbers, which are good. And it talks about like doing things like polymorphism to try to get rid of if-then statements and stuff like that. Someone was just talking about trying to get rid of polymorphism in Python with like vector operations here. So there are ways of doing this. We talked about the factory pattern. I really think it's hard to get at the factory pattern unless we get to a more complicated system here. But again, that's often where we're trying to create objects without a constructor, without doing a new here, and often create different kinds of objects that all implement the same interface or all inherit from the same parent for that. So, okay. I want to show you and have you play with one more thing here. And I think this will work. So with the quiz, you can use AI to help you, but I want to make sure that I'll just warn you, I have run the quiz through AI, and I know where AI gives the wrong answers on the quiz stuff. So I'm fine with you using AI, but I'm reminding you that the AI does not, AI gets so if you want a B on the quiz, you can just do all AI and get a B on the quiz pretty well. If you want an A on the quiz, AI makes a couple of mistakes. I think on the 5 question that makes like 2.5 mistakes on 2.5 of the questions there. So you can certainly use AI, but review the answers and make sure they make sense and answer the questions correctly. So related to this, I don't know if you've heard about Notebook LM. I think I've talked about it in this class. So I've added you to this, so you should have access to this Notebook LM system. So this is a Google Notebook tied to their language model here. It has our full textbook here for this textbook and our syllabus here. So it has the full adaptive code, second edition text. It has our syllabus. It has stuff from the first 3 units. I should post in the other units here, but you can then ask it any question here. So let's go to our review here. So I just want you to try to ask it some questions and see how it does for this here. So let's say, well, in our text, we didn't talk about it, but there's this Scrum and there's Kanban. And let's say I wanted to know what is the difference. And again, so it's like asking a large language model, but it should be pulling things from our textbook rather than the whole internet there, and providing you with citations for those stuff. So it's showing these, and then it should also be showing where it's getting this from for this. So it's going to jump to the textbook and highlight these differences for you. So again, so I was trying to decide if I should let you use AI in this for this quiz, and I could not figure out how not let you use AI if I was going to let you, if it was open book, I thought, well, if it's open book, I might as well make it that you can use AI for this. And then I thought, well, some of you might have access to AIs, and some of you might not be used to that. So then I thought, well, what I'm going to do is give you access to this AI. You don't have to use this AI in the test, but everyone has access to this AI, and our full textbook is in there. So I thought I'd do this. Also, I might be stretching the copyright rules a little bit by putting the entire textbook in this AI. And I thought as a 10-year professor, it might be better for me to stretch the copyright rules rather than having you stretch the copyright rules for that. So I thought that would be okay there for this. So this is our AI. It's a notebook, and you can ask questions from it. I don't know if you've worked with this, but again, you should be able to create your own notebooks here. I'm logged in. So again, this is using Gemini. It's really interesting. This is what I found before, is that this is an experimental thing. And so it's using Gemini for this too. But again, I can't use Gemini. Well, last year I could use Gemini because I was in an experimental group of Gemini features. But generally, your CSS accounts, for some reason, we haven't figured this out yet, is blocking Gemini, I think, still, Google Gemini. But you should be able to create these notebooks and set these up. And again, you can just add sources. So you can create your own sorts of notebooks here and add sources to them for this stuff. I don't know. I think you are just a viewer to this notebook. So I don't think you can necessarily add sources to this notebook. I'm trying to remember how I just shared it with you. And I think when I shared it, yeah, you are just shared as a viewer, not as an editor for this notebook. For this. So I thought that would be fun here. Okay, I'm going to start popping up my I want to watch for Leah. She'll be here in about 10 minutes, probably. Okay. So, that's this review and this notebook where you can ask it questions. We're gonna do a learning activity, like I say, on Thursday. We keep talking about these microservices, but I get, and again, we have this textbook talk about, but we really haven't built any yet or seen how they work. So I really want to build a simple microservice thing with Docker where we have a couple little services running in their own, each in their own Docker container and communicating with RESTful APIs back and forth. So because then I think once you kind of seen that once, then when as we go on and read more things, it'll make more sense. So that's what I want to do this week is to build an actual microservice sample, kind of a hello world microservice Docker app that just does the basics of that here. There's one that is in Microsoft Learn, but I don't think it's good for a first one. So we'll do that later on as our like a second one. But I think it's even a little bit too complicated for us to start with here. So we'll do that. So again, I'm still working on it. I'll try to get that finished hopefully tomorrow and post it. And then Thursday we'll walk through it for that. Also still trying to decide if I want to do it in individuals or groups. Right now I'm leaning to having you each do it individually, but we'll see. And the quiz is here. You can take the quiz again anytime between now and Sunday. Make sure you have 90 minutes to complete the quiz, and there's 5 essay questions that you have to read and answer. So each essay question is like half a page or so of text, pictures, stuff like that. A number of them have you go out and read something, an article or a posting, and come back and answer questions based on that. So. All right, anything else? Well, why don't we just wait a little bit for Leah to show us do stuff. So Peel, why don't you just spend some time reviewing the material so far here. Oh, did I do a posting this week? We need to do a posting. Let me do that. Yeah, we do. Otherwise, you'll be so sad. So, um, Okay, that gives you something to do now. So for the discussions, you just have to post a review question or answer a review question or post an article or related to something we've covered so far. Oops, you can't see that. Okay.